Hello, in this lecture we will find out the length of line segment MN. In the drawing we have square ABCD. We know that one side of square ABCD is equal to 12 units, that is to say AB equals to BC equals to CD equals to DA equals to 12 units. And inside this square we have a circle and a semicircle. The center of this circle is at point M. The center of this semicircle is at point N, and we want to find out the distance between the two centers, so the length of line segment MN. Okay, so first of all, we will define the point of tendency of tangent AB with this circle as point P. We define the point of tendency of tangent BC with this circle as point Q. And we also define the point of tendency of tangent AC with this circle as point R. We will define the point of tendency of tangent AC with this semicircle as point S. And we will define the touching point of the semicircle with side DC of the square as point T. And we will also define line segment PB as A. So we know that PB equals to A units and AB equals to 12 units, and therefore the value of the length of line segment AP will be equal to AB minus PB. That is to say, it will be equal to AB, that is 12 units, minus PB, that is A. In conclusion, we found out that the length of line segment AP will be equal to 12 minus A. In the next step, I will present to you a new rule. That is actually rule number 1. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. I will read rule number 1 again. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 1? The meaning of rule number 1 is that if we have this circle and we also have this point P. Point P is an external point in relation to this circle. Why point P is an external point in relation to this circle? Because of the fact that point P is not located inside this circle, nor on this circle, but it is located outside of this circle. Therefore, point P is defined as an external point in relation to this circle. So if from the external point P we draw two tangents to this circle, the first tangent will be this tangent, and we'll define the point of tendency of the first tangent with this circle as point A. We will draw a second tangent to this circle, find the point of tangency of the second tangent with this circle as point B. So the length of two tangents here, the length of the first tangent is PA or AP, PA, it is the same, and the length of the second tangent is PB. And according to rule number 1, the length of two tangents, that is to say PA and PB, from a common external point, that is to say from the common external point, point P, to a circle, 2 points A and B, that is the points on the circle itself, are equal. That is to say, PA is equal to PB. So whenever you draw two tangents to a circle from a common external point, like in this drawing, then the length of those two tangents will be equal to each other. In this case, PA equals to PB. Okay? You can implement rule number 1 in our drawing. Here we have the common external point, point B. From the common external point, point B, we have two tangents to this circle. The first tangent is tangent BP, and the second tangent is tangent BQ. And according to rule number 1, the lengths of those two tangents are equal to each other. That is to say, BP is equal to BQ according to rule number 1. But according to our definition, BP is equal to A. So we can write here that BP equals to A. And from this equation, A equals to BP equals to BQ, we will derive that BQ is also equal to A. Okay, BQ is also equal to A, so we can write here that BQ equals to A. And what is the value of line segment QC? Here it is very easy to see from the drawing that the value of the length of line segment QC will be equal to BC minus BQ. I'll repeat again, the length of line segment QC will be equal to BC minus BQ. So QC will be equal to BC, that is 12 units, minus BQ, that is A. So in conclusion, we found out that QC is also equal to 12 minus A. So we can write here that QC is equal to 12 minus A. In the next step, we will focus on the external point, point A. From the external point, point A, we have two tangents to this circle. The first tangent is tangent AP, and the second tangent to this circle is tangent AR from point A. And according to rule number 1, the lengths of those two tangents are equal to each other. So, according to rule number 1, AP is equal to AR. But according to what we have already found out, AP equals to 12 minus A. AP is equal to 12 minus A. So from this equation, 12 minus A equals to AP equals to AR. We will conclude that AR is also equals to 12 minus A. AR is also equals to 12 minus A. So you can write here that AR is also equals to 12 minus A. We will continue to focus on the external point, point A. From the external point, point A, we have two tangents to the semicircle. The first tangent is tangent AD. Tangent AD is tangent to the semicircle at point D. And the second tangent from point A to the semicircle is tangent AS. Tangent AS is tangent to the semicircle at point S. Point S is the point of tendency. And according to rule number 1, the lengths of those two tangents that exited from point A are equal to each other. That is to say, AD is equal to AS according to rule number 1. But it is given us in the question that AD is equal to 12 units. It is one side of square ABCD that equals to 12 units. So from this equation, 12 equals to AD equals to AS, we will derive that AS is also equals to 12 units. So here we can write down that AS is equal to 12 units. And what is the value of line segment RS? Here it is very easy to see from the drawing that the length of line segment RS is equal to AS minus AR. I repeat again, the length of line segment RS equals to AS minus AR. RS equals to AS minus AR. So RS is equal to AS, that is 12, minus AR. We already found out that AR equals to 12 minus A. In conclusion, we found out that RS is equal to 12 minus 12 minus is plus A. 12 minus 12 is 0. So in conclusion, we found out that RS equals to A units. So we can write here that RS is equal to A units. Here we will focus on the external point, point C. From the external point, point C, we have two tangents to this circle. The first tangent is tangent CQ. And the second tangent from point C is CR. And according to rule number 1, the lengths of those two tangents are equal to each other. That is to say, CQ is equal to CR, according to rule number 1. But we have already found out that CQ equals to 12 minus A. So from this equation, 12 minus A equals to CQ equals to CR, we will conclude that CR is also equals to 12 minus A. Okay, CR is also equals to 12 minus A. So we can write here that CR is equal to 12 minus A. And what is the value of line segment SC? it is very easy to see from the drawing that the length of line segment SC is equal to RC minus RS. I'll repeat again. SC equals to RC minus RS. SC equals to RC minus RS. So SC is equal to RC, that is 12 minus A, minus RS, that is A. So in conclusion, we found out that SC equals to 12 minus A minus A, that is to say it equals to 12 minus 2A. So we found out that SC equals to 12 minus 2A. We can write here that SC is equal to 12 minus 2A. And what is the value of diagonal AC? The value of diagonal AC, it will be equal to AR plus RC. I repeat again, the length of line segment AC will be equal to AR plus RC. So the length of diagonal AC will be equal to AR, that is equal to 12 minus A. AR equals to 12 minus A plus RC, that is also equals to 12 minus A. And here the length of line segment AC is equal to 12 plus 12 is 24, minus A is minus 2A, so in conclusion we found out that AC is equal to 24 minus 2A. AC is equal to 24 minus 2A. In the next step, I will present to you a new rule. This will be rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. I will read rule number 2 again. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if we have this circle and we know that the center of this circle is at this point O, and we also have tangent AB to this circle, here tangent AB, this tangent is tangent to this circle at this point. We define the point of tendency as point M. I'll write it down. M is the point of tendency. we will join points O and M together by a straight line. OM is the radius of this circle because of the fact that it starts from the center of the circle and ends at point M, that is a point on the circle itself. Therefore OM is the radius of this circle, so we'll define it as R, abbreviation for radius. So here we have the radius OM that is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AB in this circle. And whenever you have a radius that is drawn to the point of tendency, like in this drawing, then the tangent will be perpendicular to that radius. In this case, the tangent AB will be perpendicular to radius OM. The tangent AB will be perpendicular to the radius MO. So AB perpendicular to MO, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. I repeat again, whenever you have a radius that is drawn to the point of tendency, like in this drawing, then the tangent will be perpendicular to that radius. In this case, tangent AB will be perpendicular to radius MO, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. And we can actually implement rule number 2 in our drawing. In our drawing, we will join points M and P together by a straight line. Line segment MP is the radius of this circle because of the fact that it starts from point M, that is the center of this circle, and that's at point P, that is the point on this circle itself. Therefore, MP is the radius of this circle, and we have the radius MP of the circle that is drawn to the point of tendency, that is to say it is drawn to point P, that is the point of tendency of tangent AB with this circle. Therefore, whenever you have a radius that is drawn to the point of tendency, like in this case, then the tangent will be perpendicular to that radius. In this case, tangent AB will be perpendicular to the radius PM. So AB is perpendicular to PM, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay? And we also know that all the angles inside the square are right angles, so angle ABC, this angle that is 1 out of 4 angles of square ABCD, must be equal to 90 degrees, so it is equal to 90 degrees. In the next step, we will join points M and Q together by a straight line. Here, line segment MQ is the radius of this circle because of the fact that it starts from the center of the circle, that is to say from point M, and ends at point Q, that is the point on this circle itself. Therefore, MQ is the radius of this circle. And we have the radius MQ that is drawn to the point of tendency, that is to say it is drawn to point Q, that is the point of tendency of tangent BC with this circle. And whenever we have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to that radius. In this case, the tangent BC will be perpendicular to the radius QM, so BC is perpendicular to QM, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. So here in quadrilateral PBMQ, we have one, two, three right angles, and the sum of three right angles in 90 times 3 is 270 degrees, plus the size of the fourth angle that is actually angle PMQ, In total, the sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So here, the sum of three angles, that is 270 degrees, plus the size of the fourth angle, that is actually angle PMQ. In total, the sum of those four angles must be equal to 360 degrees. We'll subtract 270 degrees from this equation, and we'll get that the size of angle PMQ will be equal to 360 degrees minus 270 degrees. It is 90 degrees. So we found out that angle PMQ is a right angle. It equals to 90 degrees. Here angle PMQ equals to 90 degrees. So actually, quadrilateral PBMQ that has four right angles must be at least a rectangle. I will write it down. Quadrilateral PBMQ that has four right angles must be at least a rectangle. And so we relate to quadrilateral PBMQ as a rectangle, and we have also rule number 3. According to rule number 3, the opposite sides of a rectangle are equal to each other. I write rule number 3 again. According to rule number 3, the opposite sides of a rectangle are equal to each other. That is to say, the opposite sides of rectangle PBMQ are equal to each other. That is to say, PB is equal to MQ. PB equals to MQ. According to rule number 3. But PB is equal to A according to our definition. PB is equal to A, so from this equation A equals to PB equals to MQ, we will derive that MQ is also equals to A. MQ is also equals to A. Likewise, in quadrilateral PBMQ, according to rule number 3, BQ must be equal to PM. BQ must be equal to PM. I'll repeat again. According to rule number 3, BQ equals to PM. But according to what we have already found out, BQ is equal to A. So from this equation A equals to BQ equals to PM, we will derive that PM is also equals to A. PM is also equals to A. Actually, we found out that quadrilateral PBMQ is not a rectangle, but a square, because of the fact that all of its sides are equal to each other. And we have already found out that the radius of the circle is equal to A units. Okay? And in the next step, we will implement the Pythagoras theorem on the right triangle, triangle ABC. In the right triangle, triangle ABC, by PT, here in the right triangle, triangle ABC, by PT is abbreviation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AC, so the square of the hypotenuse is AC squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to AB squared plus BC squared. So according to equation number 1, AC squared, we have already found out that AC is equal to 24 minus 2A. Therefore, AC squared will be equal to 24 minus 2A squared. And it must be equal to AB squared. AB is equal to 12, so AB squared is 12 squared. Plus BC squared. BC is also 12, so BC squared will be also equal to 12 squared. So, according to equation number 1, 24 minus 2A squared equals to 12 squared plus 12 squared is 2 times 12 squared. Here we will take a root out of this equation, equation number 1, and we will get that 24 minus 2A is equal to the square root of 2 times 12. Why? Because of the fact that the square root of 12 squared is 12. Why the square root of 12 squared is 12? Because of the fact that the root cancels the square and we left only with 12. So in conclusion, we found out that according to equation number 1, 24 minus 2A equals to square root of 2 times 12. Here we will add to this equation 2A and we will subtract square root of 2 times 12 from equation number 1. And we will get that according to equation number 1, 2A is equal to 24 minus square root of 2 times 12. Here we will divide equation number 1 by 2, and we will get that according to equation number 1, A, that is the radius of the circle, is equal to 24 over 2 is 12, minus 12 over 2 is minus 6 times square root of 2. So in conclusion, we found out that the radius of the circle is equal to A, that is 12 minus 6 times square root of 2 units. Okay? In the next step, we will define the radius of the semicircle as B. Here, line segment DN is the radius of the semicircle because of the fact that it starts from the center of the semicircle, that is to say from point N, and ends at point D, that is the point on the semicircle itself. Therefore, dN is equal to the radius of the semicircle, and according to our definition, the radius of the semicircle is equal to B. Therefore, dN will be equal to B. Likewise, NT is the radius of this semicircle because of the fact that it starts from the center of the semicircle, that is to say from point N, and ends at point T, that is a point on this semicircle itself. Therefore, NT is the radius of this semicircle, that is to say it equals to B. And what is the value of TC? The value of TC it is very easy to see from the drawing that the value of line segment TC is equal to DC minus DN minus NT. I repeat again. The value of line segment TC will be equal to DC minus DN minus NT. And DC is equal to 12 units. It is one side of square ABCD that equals to 12 units, minus DN, that is actually the radius of the semicircle, that is B, minus DC, that is also the radius of the semicircle, that is also B. So in conclusion, we found out that TC equals to 12 minus B minus B, 12 is 12 minus 2B, so TC is equals to 12 minus 2B. So we can write down here that TC is equal to 12 minus 2B In the next step, we will join points N and S together by a straight line. Line segment NS is the radius of the semicircle because of the fact that it starts from the center of the semicircle and ends at point S, that is a point of the semicircle itself. Therefore, NS is the radius of the semicircle, that is to say it equals to B units. And here we have the radius of the semicircle, that is NS. The radius NS, it is drawn to the point of tendency, that is to say it is drawn to point S, that is the point of tendency of tangent AC with this semicircle, and whenever we have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to that radius. In this case, the tangent AC will be perpendicular to the radius SC. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. According to rule number 2, of course. And because of the fact that angle NSC is a right angle, therefore triangle NSC will be a right triangle. So we will implement the Pythagoras theorem on the right triangle, the right green triangle, triangle NSC. But before that, we will calculate the length of the hypotenuse NC. What is the length of the hypotenuse NC of the right green triangle, triangle NSC? The length of the hypotenuse NC, from the drawing it is very easy to see that the length of the hypotenuse NC, the hypotenuse NC is equal to NT plus TC. I'll repeat again. The length of the hypotenuse NC of the right green triangle, triangle NSC equals to NT plus TC. But NT is equal to B, it is the radius of the semicircle. And TC is equal to 12 minus 2B. So, in conclusion, we found out that the hypotenuse NC is equal to 12 and B minus 2B is minus B. In conclusion, the hypotenuse NC of the right green triangle NSC is equal to 12 minus B. So we can write here that the hypotenuse NC is equal to 12 minus B. Now we can implement the Pythagoras theorem on the right green triangle, triangle NSC. So according to Pythagoras theorem, here PT is the abbreviation for Pythagoras theorem on the right green triangle, triangle NSC. This will be equation number 2. The square of the hypotenuse is NC squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to NS squared plus SC squared. I will repeat again. In the right green triangle, triangle NSC, according to Pythagoras theorem, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. The hypotenuse is NC, so the square of the hypotenuse is NC squared. It must be equal to the sum of the squares of the perpendiculars. This is to say, it must be equal to NS squared plus SC squared. So here NC is equal to 12 minus B, so NC squared is 12 minus B squared, and it must be equal to NS squared. NS is B, so NS squared is B squared, plus SC squared. SC is 12 minus A, so 12 minus 2A, so SC squared will be equal to 12 minus 2A squared. So in conclusion, it's found out that according to equation number 2, 12 minus B squared equals to B squared plus 12 minus 2A squared. So here we'll find out the value of the expression 12 minus 2A. What is the value of 12 minus 2A? The value of 12 minus 2A will be equal to 12 minus 2 times A, and A equals to 12 minus 6 times square root of 2. So here it will be equal to 12 minus 2 times 12 is minus 24. Minus 2 times minus 6 times square root of 2 is plus 12 times square root of 2. So it equals to 12 times square root of 2. 12 minus 24 is minus 12. So in conclusion, we found out that 12 minus 2A is equal to 12 times square root of 2 minus 12. Here we take 12 as a common factor out of this expression, and we get it is 12. Inside the brackets, what is left from 12 times square root of 2 after we took 12 as a common factor? What is left is actually square root of 2, and what is left from minus 12 after we took 12 After we took from it 12 as a common factor, what is left? It is actually minus 1. So in conclusion, we found out that 12 minus 2a is equals to 12 times square root of 2 minus 1. Okay, so actually we can substitute 12 minus 2a in equation number 2 by 12 times square root of 2 minus 1. We will do it now, and we'll get that according to equation number 2, twelve minus b squared equals to b squared plus 12 minus 2a squared, and we will substitute 12 minus 2a squared by 12 times square root of 2 minus 1 squared. So here we actually got that according to equation number 2, we'll open the brackets here. 12 minus b squared is 12 squared plus b squared minus 2 times 12 times b, that equals to b squared, and here we have 12 times square root of 2 minus 1 squared. Here, according to the algebraic identity that states that x times y to the power of m is equal to x to the power of m times y to the power of m. According to this algebraic identity, we will get that the expression 12 times square root of 2 minus 1 squared, all is squared. It will be equal to 12 squared times square root of 2 minus 1 squared. Okay? So here we have b squared on both sides of the equation, so b squared will get cancelled. And what is left from equation number 2 after we cancelled b squared? What is left? It is actually 12 squared minus 2 times 12b is minus 24b, that equals to 12 squared, and we have here inside the brackets 12 minus 1 squared. 12 minus 1 squared equals to actually 2 minus 1 square, square root of 2 minus 1 square. Square root of 2 square is 2, plus 1 square is plus 1, minus 2 times square root of 2 times 1. So according to equation number 2, we got that 12 square minus 24b is equals to 2 times 12 square plus 1 times 12 square minus 2 times square root of 2 times 12 square. So here we actually have 12 square on both sides of the equation, so 12 square will get cancelled. And what is left from equation number 2 after we cancelled 12 square? What is left? It is actually minus 24b is equals to 2 times 12 squared is 144. 144 times 2 is 288. And we have here 12 squared that is equals to 144. 144 times minus 2 is minus 288. And we also have to multiply it by square root of 2. So here we will divide the equation number 2 by minus 24, and we'll get that according to equation number 2, minus 24b over 24 is minus b, that equals to 288 over 24 is 12, and minus 288 over 24 is minus 12, and we also have to multiply it by square root of 2. Here we will multiply equation number 2 by minus 1, and we'll get that minus b times minus 1 is b, that equals to 12 times square root of 2 minus 12. So we found out the value of b, that is actually the radius of the semicircle. The radius of the semicircle equals in its length to 12 times square root of 2 minus 12. And we have already found out that A is equal to 12 minus 6 times square root of 2 units. And what is the value of A plus B? Here, A plus B will be equal, from the two equations here, you can see that A plus B will be equal to minus 12 plus 12 is 0, and 12 times square root of 2 minus 6 times square root of 2 is 6 times square root of 2. So in conclusion, we found out that A plus B is equal to 6 times square root of 2 units. So in the next step, we will join points M and R together by a straight line. MR, line segment MR, is the radius of this circle because of the fact that it starts from the center of this semicircle, of this circle, that is actually from point M, and ends at point R, that is the point on this circle itself. Therefore, MR is the radius of this circle, that is to say it equals to A, because the radius of this circle is equals to A. So here we have the radius MR that is drawn to the point of tendency, that is to say it is drawn to point R, that is the point of tendency of tangent AC with this circle, and whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to that radius. In this case, the tangent AC will be perpendicular to the radius RM. So AC is perpendicular to RM. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. In the next step, we will do a construction from point A, from point M. We will draw perpendicular on RM. So here, from point M, we will draw perpendicular on RM. So this angle will be equal to 90 degrees, according to our construction. And then from NS, from the radius NS, NS is the radius of the semicircle, so from the radius NS, we will extend the radius NS, we will extend the radius NS by a straight line until it intersects with the perpendicular from point M. and we define the intersection point of the extended NS and the perpendicular from point M as X. Here NS is the radius of the semicircle that equals to B units. Therefore NS is a radius, it must be a straight line. So NS is a straight line, and when we extended the straight line NS by a straight line, we got NX. Therefore NX must be also a straight line because of the fact that when we extend the straight line by a straight line, the result must be a straight line. That is to say, when we extended the straight line NS by a straight line, we got the line segment NX, so the line segment NX must be also a straight line. Because when you extend a straight line by a straight line, the result must be a straight line. Therefore NX is a straight line. We can write down here that NX is a straight line. NX is a straight line. And we also have rule number 4. According to rule number 4, the sum of the angles on one side of a straight line is equal to 180 degrees. I read rule number 4 again. According to rule number 4, the sum of the angles on one side of a straight line is equal to 180 degrees. So if we have the straight line NX, if we focus on the upper side of the straight line NX at point S, then the sum of its angles at point S must be equal to 180 degrees. So which angles we have at point S? On the upper side of NX, we have here 90 degrees, and we have also angle RSX. So 90 degrees plus the size of angle RSX, in total they must be equal to 180 degrees according to rule number 4. I repeat again. The sum of the angles on the upper side of the straight line NX at point S must be equal to 180 degrees. That is to say 90 degrees plus the size of angle RSX. In total they must be equal to 180 degrees. Here 90 degrees plus the size of angle RSX must be equal to 180 degrees according to rule number 4. We will subtract 90 degrees from this equation and we will get that the size of angle RSX is equal to 180 degrees minus 90 degrees, it is 90 degrees. So we actually found out that angle RSX is a right angle, it equals to 90 degrees. So here, this angle RSX is a right angle. So actually, in quadrilateral RMSX, we have 1, 2, 3 right angles, and the sum of 3 right angles is 270 degrees. 270 degrees plus the size of this angle MXS, In total, they must be equal to 360 degrees. I repeat again, in quadrilateral RMSX, the sum of the angles must be equal to 360 degrees. Therefore, the sum of three angles, the sum of three right angles that it has, it is 270 degrees, plus the size of the fourth angle that is actually angle MXS. In total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We subtract 270 degrees from this equation, and we'll get that angle MXS, the missing angle, is equal to 360 degrees minus 270 degrees. It is equal to 90 degrees. So we found out that this angle is a right angle. It equals to 90 degrees. We actually found out that in quadrilateral RMSX we have four right angles, and any quadrilateral that has four right angles must be at least a rectangle. Therefore, quadrilateral RMSX that has four right angles must be at least a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, in quadrilateral or in rectangle, RMSX, in rectangle RMSX, the opposite sides are equal to each other. That is to say, RM is equal to SX. I will repeat again. According to rule number 3, in rectangle RMSX, RM must be equal to SX. But we have already found out that Rm equals to A, it is the radius of the circle. So from this equation, A equals to Rm equals to Sx, we will derive that Sx is also equals to A. Here, Sx equals to A. Likewise, in rectangle RMSX, we know that Mx must be equal to Rs, or Rs must be equal to Mx according to rule number 3. I repeat again, in rectangle RMSX, Rs must be equal to Mx according to rule number 3, but we have already found out that Rs equals to A. So from this equation, A equals to Rx equals to Mx, we will derive that Mx is also equals to A. Mx is also equals to A. Here, Mx is also equals to A. So we actually found out that quadrilateral RMSX is not a rectangle but a square, because of the fact that all of its sides are equal to A. So, and because of the fact that angle MXN is equal to 90 degrees, therefore triangle MXN is a right triangle. So we will implement the Pythagoras theorem on the right orange triangle, triangle MXN. according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is mn, so the square of the hypotenuse is mn squared. And it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to mx squared plus xn squared. Okay? So, in the right orange triangle MXN, by Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say, mn squared equals to mx squared plus xn squared, according to equation number 3. So, mx is equal to a, so mx squared is a squared, plus xn squared. xn is equal to a plus b, so xn squared is equal to a plus b squared, and it must be equal to the square of the hypotenuse, that is actually mn squared. So in conclusion, according to equation number 3 in Pythagoras theorem, we got that a squared plus a plus b squared must be equal to mn squared. We have already found out that a is equal to 12 minus 6 times square root of 2. Therefore, a squared will be equal to 12 minus 6 times square root of 2 squared, plus a plus b. We have already found out that a plus b equals to 6 times square root of 2. Therefore, a plus b squared will be equal to 6 times square root of 2 squared. And it is equal to the square of the hypotenuse, that is actually mn squared, that is missing line segment that we are looking for in this question. So here, we will open the brackets here. 12 minus 6 times square root of 2 square will be equal to 12 square, plus 6 times square root of 2 square. It is equal to 6 squared, that is 36, times square root of 2 squared, that is 2, and 36 times 2 is 72. Minus 2 times 12 times 6 times square root of 2, plus 6 times square root of 2 square, 6 times square root of 2 square equals to mn squared. So here we have 12 square. 12 square is 144. Plus 72. Here we have 6 times square root of 2 square. Actually, square root of 2 square is 2, and 6 square is 36, and 36 times 2 is 72. Minus 6 times minus 2 is minus 12, minus 12 times minus 12 is minus 144 times square root of 2, that equals to mn square or nm square. '72 plus 72 is 144, and 144 plus 144 is 2 times 144, minus 144 times square root of 2, it is equal to nm squared. Here we will take 144 as a common factor out of those two expressions. So 144 was taken as a common factor. What is left from 2 times 144? What do we do from it? 144 is a common factor. What is left? It is actually 2. And what is left from minus 144 times square root of 2. After we took from it 144 is a common factor. What is left? It is actually minus square root of 2, and it is equal to mn squared. Here we'll take a root out of this equation number 3, and we'll get that according to equation number 3, the square root of 144 is 12, and here it will be inside the square 2 minus square root of 2. That is actually the value of mn. So we actually found out that the length of mn, that is actually the distance between the centers of the semicircle and the circle, it is equal to either 12 times the square root of 2 minus square root of 2 units, or in terms of numbers, it equals to 9.18 units. That is the answer to the question. I will repeat again. The distance between the centers of the semicircle and the circle, that is to say, the length of line segment mn, it is equal to either 12 times square root of 2 minus square root of 2 units, or in terms of numbers, it equals to 9.18 units. In the next step, I will summarize the lecture. Actually, we wanted to find out the distance between the centers. We wanted to find out the distance between the centers of the circle and the semicircle. That is actually the length of line segment mn. Inside the square ABCD, that one side of it is equal to 12 units. We have the circle and the semicircle, and we want to find out the distance between the centers of the semicircle and the circle. That is to say, the length of line segment mn. So I defined the point of tangency between tangent AB and this circle at this point, point P. We defined the point of tangency of tangent BC with this circle at this point as point Q. We defined the point of tangency of tangent AC with this circle as point R, and we defined the point of tangency of tangent AC with this semicircle as point S, and we defined the touching point of the semicircle with side DC as point T. We defined line segment PB as A, that is to say, the length of line segment PB equals to A units. And here, if PB equals to A and AB equals to 12, AP will be equal to AB minus PB, that is to say, AP, line segment AP will be equal to AB, that is 12, minus PB, that is A. So in conclusion, AP equals to 12 minus A. Then I presented to you rule number 1. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. Okay, so here point P is an external point in relation to this circle because of the fact that point P is not located inside this circle nor on this circle, but is located outside of this circle. Therefore, it is defined as an external point in relation to this circle. So if from the external common point, point P will draw two tangents to this circle, the first tangent is PA. The point of tangency between the first tangent and the circle is point A, and the second tangent is PB. The point of tangency of the second tangent with this circle is at point B. So in this case, the lengths of those two tangents will be equal to each other. That is to say, PA is equal to PB. So whenever you draw two tangents to a circle from a common external point, then the length of those two tangents will be equal to each other. In this case, PA is equal to PB. we can implement rule number 1 in our drawing. In our drawing we have a point B. Point B is defined as a common external point in relation to this circle, because it is not located inside this circle nor on this circle, but it is located outside of this circle. Outside of this circle, therefore it is an external point in relation to this circle. So from the external point, point B, we have two tangents to this circle. The first tangent is tangent BP, and the second tangent is tangent BQ. And according to rule number 1, the lengths of those two tangents, the lengths of those two tangents must be equal to each other. That is to say, BP must be equal to BQ, according to rule number 1. But we have already defined BP as A, so from this equation A equals to BP equals to BQ, we will derive that BQ is also equals to A. So you can write here that BQ equals to A, and what is the length of line segment QC? The length of line segment QC will be equal to BC minus BQ. Again, QC equals to BC minus BQ, so QC equals to BC, that is 12 units, minus BQ, that is A. So in conclusion, we found out that QC is also equals to 12 minus A, exactly like AP. Then we focused on the external point, point A. From the external point, point A, we have two tangents to this circle. The first tangent is tangent AP. The second tangent is tangent AR. And according to rule number 1, they must be equal to each other. So here, AP must be equal to AR according to rule number 1. But we have already found out that AP equals to 12 minus A. So from this equation, 12 minus A equals to AP equals to AR. We will conclude that AR is also equals to 12 minus A. AER is also equals to 12 minus A. We continued to focus on the external point, point A. From the external point, point A, we have two tangents to this semicircle. The first tangent is tangent AD, the point of tendency is point D. The second tangent to this semicircle is AS, the point of tendency is point S. And according to rule number 1, the lengths of those two tangents must be equal to each other. That is to say, AD must be equal to AS, according to rule number 1. Here AD must be equal to AS, according to rule number 1. But we know that AD equals to 12 units because it is one side of square ABCD, and all the sides of square ABCD equals to 12 units. So AD must be also equal to 12 units. So from this equation, 12 equals to AD equals to AS, we will derive that AS is also equals to 12 units. Okay, here AS is equal to 12 units. So if AS equals to 12 units and AR equals to 12 minus A, what is the length of RS? It is very simple. The length of RS will be equal to AS minus AR. Okay, RS equals to AS minus AR. AS equals to 12, AR equals to 12 minus A. So RS equals to 12 minus 12 minus A. We open the brackets and we got that 12 minus 12 is 0. Minus and minus is plus. So in conclusion, we found out that RS equals to A units. Then we focused on the external point, point C. Here from the external point, point C, we have two tangents to this circle. The first tangent is tangent CQ, and the second tangent is tangent CR. And according to rule number 1, they must be equal to each other. Okay, here CQ must be equal to CR according to rule number 1, but we have already found out that CQ equals to 12 minus A. So from this equation, 12 minus A equals to CQ equals to CR, we will derive that CR is also equals to 12 minus A. Here CR is also equals to 12. CR is also equals to 12 minus A. Okay? And what is the value of line segment SC? The value of line segment SC it will be equal to RC minus RS. Again, SC will be equal to RC minus RS. Okay, here SC will be equal to RC minus RS. RC equals to 12 minus A, RS equals to A, so SC will be equal to 12 minus A minus A. 12 minus A minus A is 12 minus 2A. So in conclusion, we found out that SC, line segment SC equals to 12 minus 2A. And what is the value of diagonal AC? The value of diagonal AC, it is equal to AR plus RC. The value of diagonal AC equals to AR plus RC. AR equals to 12 minus A. RC is also equals to 12 minus A. So AC will be equal to 12 minus A plus 12 minus A. 12 minus A plus 12 minus A is 12 plus 12 is 24. Minus A minus A is minus A plus minus A is minus 2A. So in conclusion, we found out that the length of diagonal AC is 24 minus 2A. Okay, then I presented to you rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So we have this circle, the center of this circle is at point O, this point, and we have also tangent AB that is tangent to this circle is at point M. Point M is the point of tendency of tangent AB with this circle. OM is the radius of this circle because of the fact that it starts from the center of the circle and ends at point M, that is the point on the circle itself. So we have here the radius OM, it is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AB with this circle, and whenever we have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to that radius. That is to say AB, tangent AB will be perpendicular to the radius MO. That is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. So we can implement rule number 2 in our drawing. Here we will join points M and P together by a straight line. MP is the radius of this circle because of the fact that it starts from point M, that is the center of this circle, and ends at point P, that is the point on this circle itself. Therefore, MP is the radius of this circle, and we have the radius MP, it is drawn to the point of tendency, that is to say, it is drawn to point P, that is the point of tendency of tangent AB with this circle. And whenever we have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to that radius. That is to say, tangent AB will be perpendicular to radius PM. AB perpendicular to PM, that is to say this angle equals to 90 degrees and this angle will be also equal to 90 degrees. And we know that all the angles inside the square are right angles, that is to say angle ABC, this angle that is 1 out of 4 angles of square ABCD must be equal to 90 degrees. We join points M and Q together by a straight line. MQ is the radius of the circle because of the fact that it starts from the center of the circle, that is to say from point M, and ends at point Q, that is a point on this circle itself. Therefore, MQ is the radius of this circle, and we have the radius MQ that is drawn to the point of tendency, that is to say it is drawn to point Q, that is the point of tangency of tangent BC with this circle. And whenever you have a radius that is drawn to the point of tangency, the tangent will be perpendicular to that radius. In this case, tangent BC will be perpendicular to the radius QM. BC is perpendicular to QM, that is to say this angle equals to 90 degrees and this angle will be also equal to 90 degrees. So in quadrilateral PBMQ we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. 270 degrees plus the size of the fourth angle, that is actually angle PMQ. In total, they must be equal to 360 degrees. In quadrilateral PBMQ, the sum of 3 angles, that is 270 degrees plus the size of the fourth angle. In total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We subtract the 270 degrees from this equation and we got that the value of the fourth angle, that is actually angle PMQ, equals to 360 degrees minus 270 degrees, that is to say it equals to 90 degrees. So angle PMQ, this angle is a right angle, therefore in quadrilateral PBMQ, we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle. So we relate to quadrilateral PBMQ as a rectangle. And then I presented to you rule number 3. According to rule number 3, the opposite sides of a rectangle are equal to each other. That is to say, the opposite sides of a rectangle PBMQ are equal to each other. They are equal to each other. It means that PB is equal to MQ. PB equals to MQ according to rule number 3, but we have, according to our definition, PB equals to A. So from this equation, A equals to PB equals to QM. So to MQ, we derive that MQ is also equals to A. Here, MQ is also equals to A. Likewise, according to rule number 3, BQ must be equal to PM. BQ must be equal to PM. But we have only found out that BQ equals to A. So from this equation, A equals to BQ equals to PM, we derive that PM is also equals to A. Here, PM is also equals to A. So we actually found out that quadrilateral PBMQ is a square because of the fact that all of its sides are equal to each other. Then we implemented the Pythagoras theorem on the right triangle, triangle ABC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars in the right triangle ABC. The hypotenuse is AC, so the square of the hypotenuse is AC square, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to AB square plus BC square. So AC is 24 minus 2A, so AC square is 24 minus 2A square. AB is 12, so AB square is 12 square. BC is 12, so BC square is also 12 square. So we got that according to equation number 1, 24 minus 2A equals to 12 square plus 12 square. 12 square plus 12 square is 2 times 12 square. That equals to 24 minus 2A square. So we took a root out of this equation, equation number 1, and we got that according to equation number 1, 24 minus 2A equals to the square root of 2 times the square root of 12 squared. The square root of 12 squared is 12 because of the fact that the root cancels the square and we left only with 12. So in conclusion, we got that according to equation number 1, 24 minus 2A equals to the square root of 2 times 12. Here we added to this equation to A and we subtracted the square root of 2 times 12, and we got that according to equation number 1, 2A equals to 24 minus square root of 2 times 12. We divided equation number 1 by 2, and we got that A equals to 24 over 2 is 2, and minus 12 over 2 is minus 6. So here, in conclusion, we got that A, that is the radius of the circle, equals to 12 minus 6 times square root of 2 units. Then we found out, actually we defined the radius of the semicircle as B, therefore dn will be equal to B and nt will be also equal to B. What is the value of line segment TC? From the drawing, it is very easy to see that the value, the length of line segment TC will be equal to DC minus dn minus nt. Here nc equals to TC. Here TC equals to DC minus dn minus nt. So TC equals to DC, that is 12, minus dn, that is B, minus dn, that is also B. In conclusion, TC equals to 12 minus B minus B. 12 minus B minus B is 12 minus 2B. So TC, in conclusion, equals to 12 minus 2B. Then we join points N and S together by a straight line. NS is the radius of this semicircle, that is to say it equals to B. And we have the radius NS that is drawn to the point of tendency, that is to say it is drawn to point S, that is the point of tendency of tangent AC with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to that radius. In this case, the tangent AC will be perpendicular to the radius SN. So AC is perpendicular, AC is perpendicular to SN, that is to say this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. So because of the fact that angle NSC is a right angle, therefore the green triangle NSC is a right triangle, so we can implement the Pythagoras theorem on the right green triangle, triangle NC. First of all, we will find out the value of the hypotenuse NC. What is the value of the hypotenuse NC? It is very easy to see from the drawing that NC is equal to NT plus TC. Here, NC is equal to NT plus TC. NC equals to NC equals to NT plus TC. NT equals to B, TC equals to 12 minus 2B. So in conclusion, NC equals to 12 minus 2B. So we implemented the Pythagoras theorem on the right green triangle, triangle NCS. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the slopes of the perpendiculars. The hypotenuse is NC, so the square of the hypotenuse is NC square, and it must be equal to the square of the sum of the slopes of the perpendiculars. That is to say, it must be equal to NS square plus SC square. NS is B, so NS square is B square. SC is 12 minus 2A, so SC square is 12 minus 2A square. So in the next step, we calculated the value of the expression 12 minus 2A. 12 minus 2A equals to 12 minus 2 times A, and A equals to 12 minus 6 times square root of 2. That is to say, here it is equal to, we open the brackets here, and we got that minus 2 times 12 is minus 24, and minus 2 times minus 6 times square root of 2 is plus 12 times square root of 2. So in conclusion, here it equals to 12 minus 24 is minus 12, and then we have 12 times square root of 2. So in conclusion, we found out that 12 minus 2A is equals to 12 times square root of 2 minus 12. Here we took 12 as a common factor out of these two expressions, and inside the brackets we have square root of 2 minus 1. So in conclusion, we found out that 12 minus 2A equals to 12 times square root of 2 minus 1. So we can substitute 12 minus 2A in equation number 2 by 12 times square root of 2 minus 1. We did it, and we got that 12 minus b squared, according to equation number 2, 12 minus b squared equals to b squared. And here we substituted 12 minus 2a by 12 times square root of 2 minus 1 squared. And here we open the brackets, 12 minus b squared equals to 12 squared plus b squared minus 2 times 12 times b. And it equals to b squared. And here we have 12 times square root of 2 minus 1 squared. According to the algebraic identity that xy to the power of m, x times y to the power of m is equal to x to the power of m times y to the power of m. The value of this expression will be equal to 12 squared times square root of 2 minus 1 squared. So here we have b squared on both sides of the equation, so b squared will get cancelled, and we left only with 12 squared minus 2 times minus 12b is minus 24b, and it equals to 12 squared. And we open the brackets here, square root of 2 minus 1 square is equal to square root of 2 squared, that is 2, plus 1 squared, that is 1, minus 2 times square root of 2. So in conclusion, we got that 12 squared minus 24b is equal to, we open the brackets here, and we have here 2 times 12 squared plus 1 times 12 squared minus 2 times square root of 2 times 12 squared. Here we have 12 squared on both sides of the equation, so 12 squared will get cancelled. And what is left from equation number 2 after we cancel 12 squared? What is left is actually minus 24b. And here 12 squared is 144. 144 times 2 is 288. And here we have minus 2 12 squared is 144. 144 times minus 2 is 288. So in conclusion, this expression equals to 288 times square root of 2. Here we divided the equation number 2 by 24. Minus 24 b over 24 is minus b. 288 over 24 is 12. Minus 288 over 12 is minus 12. So in conclusion, according to equation number 2, we found out that minus b equals to 12 minus 12 times square root of 2. We multiplied the equation number 2 by minus 1. And we got that according to equation number 2, b equals to 12 times square root of 2 minus 12. Again, b, the radius of the semicircle, equals to 12 times square root of 2 minus 12. A, the radius of the circle, equals to 12 minus 6 times square root of 2. And here, a plus b, it is very easy to see from those two equations that a plus b is equal to, here we have minus 12 plus 12 is 0. And we have 12 times square root of 2 minus 6 times square root of 2 is 6 times square root of 2. So in conclusion, we found out that a plus b equals to 6 times square root of 2. Then, here we added points R and M together by a straight line. Here RM is the radius of this circle, that is to say it equals to A. And we have the radius RM that is drawn to the point, the radius RM here, the radius MR, it is drawn to the point of tendency, that is to say it is drawn to point R, that is the point of tendency of tangent AC with this circle. And whenever we have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to that radius. In this case, the tangent AC will be perpendicular to the radius RM. So AC is perpendicular to RM, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Then we made a construction from point M, we draw perpendicular on RM. Again, from the center point M, we draw perpendicular on RM. So this angle equals to 90 degrees. And then we extended NS, that is the radius of the semicircle, we extended NS by a straight line until it intersects with the perpendicular from point M. And we define the intersection point between the extended NS and the perpendicular from point M as X. So we got here quadrilateral RMXS. But here NS is the radius of the semicircle, therefore as a radius it must be a straight line. And when we extended the radius that is a straight line by a straight line, the result must be a straight line, because when you extend a straight line by a straight line, the result must be a straight line. So the result that is NX must be a straight line. So here NX is a straight line. And we have rule number 4, that the sum of the angles on one side of a straight line is equal to 180 degrees. So we know that NX is a straight line, so if we focus on the upper side of the straight line NX at point S, the sum of the angles here must be equal to 180 degrees. Which angles we have at point S? We have here 90 degrees, and we also have angle RSX. Angle RSX. So the sum of those two angles must be equal to 180 degrees according to rule number 1. Here, 90 degrees plus the size of angle RSX must be equal to 180 degrees according to rule number 4. We subtracted 90 degrees from this equation and we got that angle RSX equals to 180 degrees minus 90 degrees. 180 degrees minus 90 degrees is 90 degrees. So we found out that this angle RSX is the right angle, it equals to 90 degrees. So in quadrilateral RMSX we have 3 right angles. And the sum of 3 right angles is 270 degrees. So 270 degrees plus the size of the fourth angle that is actually angle MXS, in total they must be equal to 360 degrees. 270 degrees, that is the sum of 3 angles, plus the size of the fourth angle that is actually angle MXS, in total they must be equal to 360 degrees. We subtracted 270 degrees from this equation, and we found out that angle MXS equals to 360 degrees minus 270 degrees, it is 90 degrees. Okay, so we found out that angle MXS, this angle is a right angle, therefore quadrilateral RMSX that has 4 right angles, it must be at least a left angle. Quadrilateral RMSX that has 4 right angles must be at least a left angle. And here we have here left angle RMSX. Quadrilateral RMSX must be at least a left angle. That is to say, RM must be equal to SX. According to rule number 3, RM must be equal to SX. But we know that RM is the radius of the circle, that is to say it equals to A. So from this equation A equals to RM equal to SX, we derive that SX is also equal to A. Here SX is also equal to A. Likewise, RS must be equal to MX according to rule number 3. RS must be equal to MX according to rule number 3. But we have already found out that RS equals to A. So from this equation A equals to RS, A equals to RS equals to MX, we derive that MX is also equals to A. Here MX is also equals to A. So here, because of the fact that angle MXN is a right angle, therefore triangle MXN is a right triangle. So the orange triangle, triangle MXN, is a right triangle, therefore we can implement the Pythagoras theorem on the orange right triangle, triangle MXN. Okay, and according to the Pythagoras theorem on the orange right triangle, triangle MXN, MN square, the square of the hypotenuse, equals to MX square plus XN square, the sum of the squares of the perpendiculars. So MX is equal to A. MXN, MX square is A square, and NX is equal to A plus B, so XN square is A plus B square. So in conclusion, according to equation number 3, A square plus AB plus A plus B square equals to MN square. We know that A equals to 12 minus 6 times square root of 2, so A square is 12 minus 6 times square root of 2 square. A plus B is 6 times square root of 2, so A plus B square will be equal to 6 times square root of 2 square. And it equals to the square of the hypotenuse, that is MN square. We open the brackets here. 12 minus 6 times square root of 2 square is 12 square, plus 6 times square root of 2 square, that is 72, minus 2 times 12 times 6 times square root of 2, plus 6 times square root of 2 square, that equals to MN square. So here 12 square is 144, here is 72, and here 6 times square root of 2 square is also 72, minus 2 times 12 is minus 2 times 6 is minus 12, minus 12 times minus 12 is minus 144 times square root of 2. So in conclusion, we found out that 144 plus 72 plus 72 minus 144 times square root of 2 equals to MN square. 72 plus 72 is 144, and 144 plus 144 is 2 times 144, minus 144 times square root of 2 equals to MN square. We took 144 as a common factor out of equation number 3, and we got that according to equation number 3, we took 144 as a common factor. So what is left from 2 times 144 after we took from it 144 as a common factor? What is left? It is actually 2. And what is left from minus 144 times square root of 2 after we took from it 144 as a common factor? What is left? It is actually minus square root of 2. So in conclusion, we got that according to equation number 3, 144 times 2 minus square root of 2 equals to MN square. We took out of this equation number 3, and we got that according to equation number 3, MN equals to the square root of 144, that is 12, times square root of 2 minus square root of 2 units. So we found out that MN is equal to either 12 times square root of 2 minus square root of 2 units, or in terms of numbers, it equals to 9.18 units. I repeat again, the distance between the centers of the semicircle and the circle itself, that is actually the length of line segment MN, equals to either 12 times square root of 2 minus square root of 2 units, or in terms of numbers, it equals to 9.18 units. Okay, thank you very much.